Okay, so you guys can see I've got something up. We are good to go. So, hello everyone. Let's just start off with, so Gareth introduced me a little bit. I'm going to add to that in terms of where do I come from. I come from South Africa. I studied biomed and electrical engineering, which was lots of fun. And when I came to Opti-Num, which is the distributor of MathWorks tools in South Africa, I started off as a consultant delivering projects. And so when we talk about consulting, we're talking about like doing some software development, some code, and actually also solving like a complex business problem. And I'll get more into that later. But in my travels, I did a finance type project in operational risk. I did a mining reporting project for a big mining process, and another one in transformer design for an electrical equipment manufacturer. So I had lots of fun with MATLAB and building those solutions there. And then I moved over to become the application engineering manager, and had lots of fun there doing some marketing stuff too. So I looked after marketing for a little while, and that's where my paths crossed with Gareth Thomas, who we had lots of fun doing wild and wonderful things for in the edu space. And so that's how I fit in. At the moment, my role is head of strategic innovation. And what that means is really trying to find ways to build a bridge between academia and industry. And for me, that's about communicating the technology so that people understand it, so that business can see the value of it. And also some project delivery in unusual projects. So for people who know me, I get really excited about things that are weird. And so we do projects that are, sometimes when they're a bit weird, then those are the ones I look after to make sure that we can maybe build them and make them amazing. So that's me, that's how I fit in. I come from Opti-Num Solutions. We've been around for about 28 years. As I mentioned, we're the sole distributor of MathWorks. We have a highly qualified team that are really passionate about finding practical solutions. So often when people say, okay, a highly qualified team, we're a smallish company. We're about 53 people, and 80% of those people are technical. And when I say technical, they are engineers and scientists, computer scientists, physicists, process engineers, all kinds and all types. And so we have a lot of fun with that. And we really believe in fostering a long-term relationship with our customers. So we have these three pillars where we kind of concentrate our capabilities so that we can build more domain knowledge and so that we can build more business in these areas. But we also do a lot of other projects, kind of represented by all these empty spaces, kind of everything in between. So I mentioned it briefly before when I said consulting, that we do consulting. And often when I used to go to SKO and things at MathWorks, people would often stop me and say, what do you mean by consulting? And there's a kind of consulting that's management consulting, that's, speaking to business problems, building solutions around that, a lot of like blue sky thinking, kind of putting processes in place. And then there's also consulting in terms of like software development and data science. And where we fit is we really fit somewhere in between and across both. So what we do is we go in, we figure out like what the business need is, and then we build a very practical solution to address that business need. And so I'll keep talking about that a little bit more as we go through. Cool. So Gareth said to me, can you please talk at this MATLAB Unite talk? MATLAB is Unite talk, and was generous enough to give me the first slot in the first one I've ever attended, which was so kind. So I thought I would pull up these pictures of like two events that we had. We had these launch events where we went on campus and we gave everybody a t-shirt and we gave away hot dogs and we had music and it was lots of fun. We played games and like Rubik's Cubes competition. And this is Gareth in the very back, in Stellenbosch in Cape Town. And we had a lot of fun organizing these events. But for me, this is almost like the beginning of like a launch event. And I started thinking about, well, like, what does it mean for MATLABers to unite? And what does it mean to be a MATLAber in the time of COVID, in the time of like this accelerated fourth industrial revolution we've all been thrown into. And we can say nice things like it's creativity and exploration, but it's actually really intense. It's quite difficult to be creative and explore when you're under pressure, when you're kind of surviving. And so it's an interesting time. I read an article in the World Economic Forum about the skills that can't be replicated by AI, and this concept of a knowledge society came up, and I thought it was really relevant to the concept of like MATLAB is uniting, because they say that like a knowledge society is based on this vast increase in data creation that's happening and information dissemination that results from all the innovation that's happening to create these information technologies. And so like a UNESCO goal is to build knowledge societies that are built on the pillars of freedom of expression, universal access to information and knowledge, respect for cultural and linguistic diversity, and quality education for all. So with that in mind, that's kind of like the feel of how I'm going to go through my presentation today. I get really excited about MATLAB and the technical stuff, but in all honesty, my presentation is a bit philosophical. Like I'm putting some things out there. It's open to questioning, and I think the theme of the kind of feel of this presentation is like food for thought. And so yeah, it'll be interesting to see what everybody thinks and see what you guys, if there are questions or comments that come up. So for today, I'm going to cover these 3 case studies. The first in behavioral clustering in housing, another one predictive maintenance in manufacturing, and the third one investigating different languages for teaching mathematical concepts. And so it's a pretty random mix. The reason for that mix is to really try and show the diversity in our team. Like everything we do is about our people, and so we use MATLAB for a lot of our consulting projects. And I thought that like this mix of these different disciplines, different industries, would show off like how we use the tools and what we get excited about with the tools. So with that in mind, I'm going to jump into the first one, which is really a case study in the housing industry. These 2 friends that are on the page here, this is Jeremy and Mpho. Jeremy is actually currently doing his master's in computer science, and Mpho she did her honors in pure maths, and she's really passionate about dark matter actually. And the 2 of them worked on this project, and when we think about this graph or this plot, this picture, it's really trying to show that this project in specifically was like to address a business problem around pricing and vacancies, and how we used data science and different algorithms to actually be able to get some business insight and help that company. And so let me talk through what that problem was. So the challenge here is the company was like a housing company. So they have lots of different buildings, different apartments, and it's a highly competitive market. It's very saturated, like at certain pricing levels. If they want to like differentiate themselves, they have to like really step out of the market, do crazy things, and they have to be careful about any price changes that they apply to their offerings. So they wanted to drive profitability through rental pricing and to protect their vacancies. And so maybe I'll just pause there and actually like this is a really like ubiquitous problem, because pricing is relevant across all industries and it's critical to the success in business. And basically anything you can sell, you could use data to set the price. And in most cases, when people are busy trying to understand pricing, they're usually trying to understand churn, like customer churn as well. And so when we took this project on, we had to build an agile, evidence-based pricing model. And so what we did is we actually turned it into an optimization problem. So you need to maximize profitability and minimize vacancies, right? Which is a really simple statement, but it's quite complex when there are so many different features and variables to consider. Also, usually the client's data is kind of limited, and so we had to add to that data with some external macroeconomic data like GDP and CPI data, and some microeconomic data like salaries and any kinds of data that it could get our hands on. And so we did that, and it was quite an exercise, and we came up with an algorithm that actually illustrates some price sensitivity as well as some price elasticity for every kind of building, every kind of unit, as well as every kind of customer, right? So we had to do clustering on the behavior of the customers, as well as clustering on the types of the building units that they were busy working on. And so what we were able to come up with is different pricing models, as well as recommendations and forecasts for the impact of that rental price on revenue and vacancies. And so when you look at some of the plots with this one on the left actually shows vacancy predictions. And what you can see is what happens is at the beginning of the year, there's actually a spike for vacancies, and then it drops off. And during the year, around the middle of the year, there's a bump. It's another spike. And so we looked at that and we started doing predictions around that and why that was happening. We also had a look at sensitivity to rental changes. You can see here that the revenue that they're getting based on their pricing change is related to the vacancies, but that these vacancies are seasonal, right? And so we could give them some indication of this, but we actually had to take some of the insight that we got, which was, that the rental increases are happening in the middle of the year, every year, which is what's leading to the vacancies. And as well, that if we shifted those, what would happen? There's sensitivity, which shows the impact of the price increases. And so that was really interesting, but we had to be able to take that one step further and make a recommendation and understand the seasonality in those vacancies. And so before I step onto this, I knew this was a technical talk, so I had a little chat to the team about what was awesome about using MATLAB with this problem. And the things that they mentioned was they were able to use Bayesian optimization, and it was really straightforward to actually implement and do some hyperparameter tuning on those models, as well as take some of the generalized linearized models and just test different and explore different algorithms with the data. I think a common one that comes up is just, how straightforward it is to have one install, one IDE, and everything just works. And so they can focus on the problem. So that was really interesting for me. So looking at that timing strategy, when we looked at the vacancies, what we had to do is actually decompose the elements of vacancy into what's the common trend, what's the seasonality in the data, and what are the residuals. And so we had to look at the behavioral trends, understand those temporal dynamics. It was really interesting. So also looking at the practical limitations and to be able to say what's the best time was actually that we could share some insight and understanding with the company about what's driving those vacancies, the time of year, the price, what external factors are happening in the economy, and then recommend and forecast, so recommend when to make the price increase and how much of a price increase to make. So yeah, so that's the first case study. I'm going to jump into another one now. I'm sure there are questions, but if there aren't, that's cool too. I will keep going unless Gareth stops me.
So Kirsten, maybe here's a question from my side. Just out of curiosity, so I think this is a common problem, and this optimization, I think many people in different industries do something similar. Just out of curiosity, your customer, were they already using MATLAB, or did you guys kind of come in with MATLAB and solve the solution and they're like, oh, this is quick and easy, or how did that work?
So that's really interesting. It's a good question. I think I skipped over one of those. So with this customer, they didn't know about MATLAB. They kind of didn't even know how to solve the problem at all. They didn't really want to know. They wanted to have the answer. And so for us, we actually climb into the tools and we give them insight for a problem like this in the form of reports and outcomes and a way to actually integrate it into their business data systems. And they didn't really understand, or they worried about the business problem. They don't have any engineering. Okay.
Cool, thanks.
Okay, cool. So here's another case study. This one is a manufacturing problem. I thought I'd point out here that we have Jason and Eunice who worked on the problem. Jason did his master's in process engineering, and Eunice did her bachelor's in mechatronics. And this project kind of falls between management consulting and software development and data science. And I'll talk to you a bit more about what that looks like now. So what did we do? So here, this is a bit of an engineering problem. So for those of you who don't know, there are manufacturers of chemicals or different reagents, and they have these really massive, expensive turbines. And the turbines will mix different reagents together in order to get a product out. And usually they work pretty well until they start collecting aggregate on the blades of the turbine. And once that happens, is a buildup that happens, and eventually it becomes so inefficient that it actually fails and it's out of action, and they have to like live without that production until it's repaired, right? So there are two costs that happen there. There's the one of the operational like output that's reduced and they can't get revenue from it, but also the cost of like repairing the asset once it's actually failed. And so what we did here, it was really negatively affecting the bottom line. It's a very expensive process for it to be held up. And we developed this algorithm to use tag and wash data to be able to identify the features that show fouling, right, in the model. And we built this model to predict the time until the wash, and then we created a web user interface so that the decision makers, the guy on the plant, can actually quickly see how his turbine's doing, when's he due for maintenance. And so the really special thing about this is that we actually did this, Eunice and Jason pulled this together in 100 hours, which was really impressive. This plot on the right-hand side just shows the kinds of like data modeling and clustering they did to be able to predict like how many washes, what's the time depth between washes, how can we predict when fouling and failing is going to happen. And so the result on this one is that we actually we're able to predict the future health of the turbines and minimize that cost implication that we were talking about. Okay, so I'm going to shoot ahead because I'm excited about this next one. So this next one was an actual investigation into, in academia, when we're teaching conceptual mathematics, what's the trade-off?
Kirsten, sorry, before you jump in, there was a question from Yaris, which I think is really cool. He's asking, why the 100 hours limit? Was that the cost of the project? Or is that just how long it took you guys to do that?
It's both. We had scoped a little bit more than that, and we were able to do it in less, but that's how much we did it in.
Cool, thanks.
Yeah. Thank you for catching the chat, Gareth. I can't concentrate on the chat, so pull me up. Cool. So this next one is about like investigating different programming languages when we're teaching maths. The team that worked with this, it was myself, and then the people who worked with me in this was Mpo, that I've explained before, and Ryan and Varushan. So Ryan studied mechanical engineering and Varushan did electrical, and they're an awesome team. And I think, in the area where this project falls, it probably falls closer to software development, but I think the question it's answering is perhaps closer to, like, we might call it a business problem, but it's actually like, it's a deep institutional problem around like at the root of it. And so let me talk some more about where that came from. So this challenge was like, okay, let's look at two different languages for how we teach conceptual mathematics in engineering, right? So total sidebar, this is how my brain works. I was thinking about something else. And hey, you guys probably don't know, but in South Africa, we have a big issue about a lot of different languages. So we have 11 government official languages, right? And across all of these people, these colorful people in South Africa, only less than 10% of them speak English. And so this debate is really common for us when we start talking about learning in your home language and mother tongue education. And on the side of that discussion, it's really critical for people's understanding and development to learn concepts in their home language. But also on the other side of that debate, it's like, well, the global language, what's the global language? And if English is the global language, then like, can you really afford to be left behind if others have done like work that you can't interpret because you don't understand the language? And so it's a difficult debate, and it's actually, I understand it's super global. It's actually not relevant to South Africa only, but it's something that's very familiar to me and to South Africans. So with that in mind, what we actually did was we took like an optimal control problem, and we worked on it, and we built it in MATLAB using MATLAB live scripts, and we built a MATLAB unit test. And then we needed to have a look at Python. And so we unpacked how we were going to do this. We took Anaconda to manage the environments. We used Python and 3.7, and we used the IDE PyCharm to be able to do our work in it and build unit tests. And then we moved it to Jupyter Notebooks so that we could actually compare it side by side with live scripts. And the result of this means that the students who would be studying these concepts would have the freedom of choice to learn in their language of preference. And I think there's something really deep about that. But I wanted to show you a little bit of the workflow because this was a new project for me and I found it interesting. And so maybe a like sidebar on that, I have done many projects in MATLAB. I think I have much more experience in MATLAB than in Python. I will show you some of the MATLAB and some of the Python. I really wanted to show you the workflow rather than, please don't believe that you should write Python code the way that I wrote it. So let's just take it from there. And I want to show you a little bit of the cool things that I liked in MATLAB and what I think is interesting about these different languages. And then also I want to just quickly pull up some interoperability that I thought is cool. It's not a 2020B feature, but it's a new feature that they can interoperate between the two of them. So with that in mind, I'm going to pull up the MATLAB first because that's probably our home ground and that's where we're all quite comfortable. So this is a linear quadratic problem. For those of you with engineering backgrounds, we're setting up our state space, our different matrices. We do a discrete linear quadratic regulator on it, and then we do some matrix multiplication to get to see how our pendulum is behaving. So the thing about the live scripts that sometimes I think we can take for granted is this ability to actually like debug as we go and to be able to see our variables in a certain space, in a certain function, and to be able to work in the command line directly with that variable in that workspace and then shift workspaces and move around. And so that was interesting. And then when we move across to a Python workflow, we can see that the very same kind of implementation, it looks much the same. We're sitting here in PyCharm. We have got our A and B matrices defined. We use different packages to be able to define our state space, and we can do the same discrete linear quadratic regulator on the problem. I think a cool thing that's worth pointing out, I know it's not a new thing, is it's just how beautiful MATLAB's matrix multiplication is. It's MATLAB, it's matrix laboratory. So, you know, this way of Python doing its matrix manipulations is good, but I thought MATLAB was pretty cool at that. So one of the things I wanted to pull out was looking at this IDE and looking at how you evaluate expressions using this like evaluation function. You evaluate them separately, and you know how things are laid out. It's really very much a software development environment. It's almost like formally leading you towards software development, right? You need to understand where's your variable, where's it defined. You know, if you had to call it outside of the IDE, how would it be called? And so that's kind of interesting, and it's really good. We then take this code and see what happens if we actually run it. We move it into Jupyter. Let me just get it up. Sorry about this. There we go. So here's a Jupyter notebook with the same code in it, and you can see that it looks quite beautiful, and it's behaving much the same as our live script, right? Oh dear, screens. So let me get the MATLAB up again. So when we look at the live script and the Jupyter Notebook together, they look really similar, right? And sometimes people will say they're the same thing, but they're really not. And I think for me, it's like all about the workflow. And when I look at the Jupyter Notebooks, to me, it's all about analysis and reporting and kind of an investigation and then a report that you can actually share easily. And it's not so much about the software development workflow. Whereas when you look at PyCharm, it's very hectic, it's very Intuit software development. Where's your variables defined? What is your environment? Have you defined it? What packages, what languages are you using? And so it's interesting that this live script and the Jupyter Notebook are quite comparable, and then PyCharm and MATLAB. So I wanted to come back and also just quickly highlight like the MATLAB live scripts and Jupyter Notebook interoperability. So again, let me just quickly show you. We have a quick example here that shows a MATLAB live script where we've got a signal processing problem, and we can call Python in order to get the Welch or the power spectral density, and we can do the same thing in Jupyter, and we can actually call the MATLAB engine to get it to give us the power spectral signal. And so that comment on interoperability is really interesting, because you might say, well, why would we do that? And I can think of a couple of reasons why, but for a start, we can think about, maybe there's something that in MATLAB has been implemented really in a robust way. It just works. Like, for example, if you wanted to do discrete signal processing with a control algorithm, like a control common filter, maybe it just works better in MATLAB, and so you can actually call MATLAB rather than rewriting it in Python. And for the same example, maybe there's something simple that's sitting in a MATLAB toolbox that you just want to pull out, and you can do that. So when I think about the interoperability, I think there is room for it. There's a lot of advantages, but it's kind of subtle to me. It's like a philosophical thing, because it's like, what are you going to get from it? You actually need to leverage the language and the workflow that's going to be best suited to your problem. And so my closing, notes on this project was teaching maths and teaching programming are not the same thing. So if I was going to teach someone programming from scratch, someone who'd never programmed ever before, I think I'd consider teaching them in MATLAB, just because it's a lower barrier to entry. They just use one IDE, and the versions are controlled and all of that. I think also developing code for an assignment is not the same as developing code for a deployed commercial application. So, I wouldn't use a Jupyter Notebook for a deployed commercial application as soon as I would use PyCharm and Python. And similarly, maybe I wouldn't use a MATLAB live script for a deployed commercial application. Maybe I would rather use MATLAB in an object-oriented infrastructure, which often people tell me they weren't even aware that MATLAB can do object-oriented. So I think another one is thinking about the consumer and how it's critical to the success of the deployed solution. So it's not really enough to just solve the problem today. It's where's it going? What are you going to build it into? How are you going to deploy it? Because that's actually setting yourself up for failure if you're going to have to do 10 times more work later when you have to deploy it. And also thinking about the workflow and the capability of the individual who's building it or the company that's building it. So what are you comfortable with? What's your current comfort zone? What's your home language? What's going to make this easier and quickest to build? And then leveraging pre-existing, right? So not reinventing the wheel. Don't rewrite the algorithm if it already exists. Cool. And so I think part of the comments here is, why should we innovate? Why should we start understanding these different arguments? Is to start thinking globally and acting locally, leverage rock solid prototyping to deployment platforms and workflows, and adapting our local skill set for the global context. And yeah, so that's kind of everything I had to say today. The the main thing I wanted to leave you with is how we really leverage a lot of the MathWorks tools to build holistic solutions for solving practical problems that are often very multidisciplinary and require a lot of cross collaboration. And I fully take on board that it was a very philosophical kind of discussion type presentation, but none of this really would be possible without our people, who are truly amazing and make this stuff happen because they're excited about the maths and they like building solutions for customers. So, and that's me.
Very good, Kirsten. Thank you very much. So there are a couple of questions in the chat that might be worth maybe spending a few words on. So Yoris is kind of asking, are there things where you think MATLAB can improve or learn from compared to Python? So I guess maybe sharing a few of the good, the bad, and the ugly that you came across between the environments. Can you share a few words on that?
Oh, yes. Can you just ask that question again? Because I was busy reading. I was like scanning the chat.
So the question is, are there things where you think MATLAB can improve / learn from Python?
I think so. I think one of the things that I like the way that MathWorks is going towards online, where people can like use MATLAB online and it simplifies access. I really can see that just using a Jupyter notebook that you open in a browser and you never had to install kind of anything, you didn't have to understand everything, perhaps, is a really good idea. I think in the same vein, sometimes trying to control an environment before you run a Jupyter notebook can also be messy. So I think there's both ways on that one. Things that MATLAB can learn. I had an interesting experience with the discrete linear quadratic regulator function, actually, where it works perfectly in MATLAB, and then I went to go have a look at how it works, and it can be implemented like in quite a short and simple way, and that's like a really simple function. But then there are other bigger, much more complex functions that take a lot more work, and I think there might be room to actually highlight the ones that are really special in MathWorks that have been built, like for example, doing discrete signal processing. That's like matrix like algorithms just work so well for that problem, and leveraging that, almost like marketing that, like taking that further. Yeah, I don't know if that answered all your questions, but that's kind of the big things I can think of at the moment.
No, that's a good answer. So Yotis called out list comprehensions. I think quite a few of us have actually used.
Oh yeah.
Python. That's actually quite an elegant thing that actually doesn't exist in MATLAB per se, right? But it's a bit of a mind teaser if you're not used to it.
Yeah. I think, the lists took some getting used to. Also the ND arrays that I just expected to always be arrays that were sometimes vectors and sometimes arrays. I think that was interesting as well. Yeah.
No, very good, very good. So thank you very much for your talk, Kirsten. So maybe just one last question. So it's clear to us that you're a strong MATLAB user and you kind of investigated Python. Was it how long did it actually take you to pick up Python? Was this kind of like a 1 hour thing, 2 hours? Is it a 20 hours, 100 hours?
I can put a number to that. I don't think I would say I like matched my MATLAB skills with my Python skills, but I think it took me like 2 days, so 16 hours to like get the environment set up, the IDE, to get like the debugging right, and then to start like climbing into the different data types and the variables, and then to like actually get going. So I think it was like a 2-day like hike up the kind of hill, and then it was still challenging after that for a while, but I think it wasn't impossible. It wasn't as, I think the barrier to entry with the environments, the IDE, like getting used to this whole world of like community forums and looking for packages on GitHub, that's like a mind shift that takes a while to get used to, but it's not unreachable.
Very good. Thank you very much, Kirsten. So